Let us continue lesson circles. Next, question number 2. If two chords, equal chords of a circle intersect within the circle, prove that the line segment of one chord are equal to corresponding segment of the other chord. Two equal chords of a circle. The circle given here. Two equal chords. 1, 2. Here given AB and CD. AB and CD are two equal chords which intersect within the circle. Let it be at M. Prove that the segments of one chord are equal to the corresponding segments of other chord. When they meet, each chord is divided into two parts. First, here the meeting point is M. So AB is divided as AM and BM. One is bigger portion, the other is smaller portion. And also CD is divided as DM and CM. Okay. Now, so here we have to prove that their corresponding segments formed are equal. That means AM equal to DM and CM equal to BM. That is to prove here. That is question. Prove that the line segment of one chord are equal to corresponding segments of the other chord. Line segment of one chord. The line segment formed on AB are AM and BM are equal to corresponding DM and B, because AM is bigger here, DM is bigger. So first to prove AM equal to DM, second prove CM equal to. Okay, so let's start here. Start with mark center of circle and draw perpendicular from the center. Construction. This is construction. Perpendicular from the center. Okay. So it will be P and Q. So that is construction. Now join this MO. Now two triangles are formed there. Okay. So let's start. Given a circle with center O. AB and CD are two equal chords. Okay, AB and CD are two equal chords. That is given. Okay. Intersect at M. Okay, to prove AM corresponding to DM. So AM equal to DM. Second, CM equal to BM equal to CM. That is to prove. Okay. Now, answer proof. Construction is written here. Construction. Draw OP perpendicular AB, OP perpendicular AB and OQ perpendicular CD. Okay, OP perpendicular AB and OQ perpendicular CD. Now, join OM. Now, two triangles. Which are triangles? Triangle OPM, triangle OQM. In OPM and OQM, OP and OQ are equal because perpendiculars. They are the distances from equal chords. Equal chords of a circle are equidistant from the center. Using that property, we can say that OP equal to OQ because OP and OQ are perpendicular. So distances are perpendicular distances. Okay. So OP equal to OQ. First one. In triangle OPM. OPM and triangle OQM. First one. OP equal to OQ. Reason, equal chords are equidistant from the center. Equal chords are equidistant from the center. Next, second one. OM equal to OM. OM equal to OM. Reason, common side. Okay. So one more is the OPM angle. OQM. They are also equal. Angle OPM equal to angle OQM. 90 degree each by construction or perpendicular. Okay. Now we have two sides equal, one angle, right angle. Among those two sides, one is hypotenuse. Which is hypotenuse? OM is hypotenuse. So one hypotenuse, one side, and one right angle represents RHS congruency, which implies triangle OPM congruent triangle OQM RHS congruency. Okay, now we have two triangles are congruent. Two triangles are congruent by RHS congruency. Then PM equal to QM. Then PM equal to QM. Okay, so write that first. That is no need to prove that one, but to get the result, we have to go with PM and QM. Then PM equal to QM, CP, CT, corresponding parts of these congruent triangles. Now we have PM and QM are equal. Now using PM and QM, we can prove that AM, DM equal and BM, CM equal. Here PM, see PM and QM are parts of AM and DM or AB and CD. Here what is AP? AP is half of AB. Okay, BQ is half of CD. So AP equal to DQ. Okay, and add the equals to these equals, then we can say that AM equal to DM. So start with that. Here, AP equal to half AB and DQ equal to half CD. Reason, perpendicular from the center to the chord bisects the chord. Okay, perpendicular drawn from the center of a circle to its chord bisects the chord. So AP becomes half AB and DQ becomes half CD, and AP and DQ are equal because AB and CD are equal. Since AB equal to CD, that is given, which implies half AB equal to half CD. Okay, correct? When AB and CD are equal, we can say that their halves are also equal, which implies what are half AB and half CD? They are AP and DQ. Then AP equal to DQ. Okay, AP equal to DQ. Let this equation be CPCD by equation 1 and let this be equation 2. Okay, let it be equation 1, let it be equation 2. Now add 1 and 2. What do we get when they are added? When two equations are added? Add 1 and 2. Add 1 and 2. Implies. Add the left side, which is left of this equation, PM. PM plus, which is left of second equation, AP. Equal to, now go to right side, QM plus, which is right side of this one, DQ. Okay, now write the sum. What is PM plus AP from the figure? PM plus AP is AM. AM equal to QM plus DQ is DM. Okay, so first part put. To prove first part over AM, DM equal. Okay, let it be equation number 3. Here we added because to get AM, AP and PM should be added. Or to get DM, DQ and QM should be added. That is why we added 1 and 2. Okay, now let's write this equation as 3. Now come to AB and CD. The whole one. Okay, here we have AM and DM are equal. Okay, equal from equal chords. Equal parts of equal chords. Corresponding chords AM and DM are equal. Then the remaining also equal. Okay, which implies AB minus AM equal to CD minus DM. Okay, subtract these equals from already equal chords. AB minus AM equal to CD minus DM, which implies, what is AB minus AM? BM equal to, second CD minus DM is CM. Now second one completed. Okay, first to prove AM and DM are equal and subtract those equal from the equal chords. Then answer over. Okay, question number 2 completed. Okay, same figure. Two equal chords of a circle intersect within the circle. Same figure, use the same figure. Let a circle with center O and two chords. AB and CD. Let them meet at M again. Okay, so what is to prove here? Line joining the point of intersection to center. Line point of intersection is M. So join OM. That is asked from the question. Makes equal angles with the chords. That means these two angles are equal. Okay. So when you join MO, now two angles are formed here. We have to prove these two angles are equal. That means AMO, DMO. Okay, equal. So to get that, construction required same as last question. Draw here also. Here also P and Q. Okay, write the same step. Given a circle with center O. Then also given AB equal to CD. Okay, to prove angle AMO equal to angle DMO. These two angles are equal. Okay, now construction. Draw OP perpendicular AB and OQ perpendicular CD. Now we have two triangles. Now starting in triangle, which are triangles OPM and triangle OQM. OP and OQ are equal. OP equal to OQ because distances from equal chords. Equal chords are equidistant from the center. Okay. Then second one, OM equal to OM. OM equal to OM. Reason common side. Now one more is the angle P, angle Q, they are equal because of perpendicular 90 degree by construction. Angle OPM equal to angle OQM 90 degree each by construction or perpendicular. Okay, which implies two triangles are congruent. Triangle OPM congruent triangle OQM. Reason RHS congruency. Now, what is to prove here? These two angles are even. These triangles are congruent. These angles are equal. Which implies, which are these angles? In this triangle, these are PMO, QMO. Implies angle PMO equal to angle QMO. CP, CT. Okay. So these are the required angle. Now just change it PMO as AMO, which implies angle AMO because PMO and AMO are same. QMO as DMO. Okay. Hence, proved. Question number 3 completed. Next, question number 4. If a line intersects two concentric circles with center O at A, B, C and D, prove that AB equal to CD. Figure given. Two concentric circles. What are concentric circles? Circles with one center or same center are called concentric circle. We can draw infinite number of circles using one center. Okay. Here two circles are given with one center. So draw two circles. One. Okay. One outside, one inside. Let this O. O be the center of both circles. Okay. That is, these circles are called concentric circle. Two circles with one center. Now given two concentric circles with center O, a line intersects them. A line. So draw a line. Given a line intersects these two circles at A, B, C, D. Okay. So this is given. Prove that AB equal to CD. To prove. Given so concentric circles. To prove AB equal to CD. AB, this AB and CD. These two parts are equal. That is to prove. These two line segments are equal. That is to prove. Okay. Here, we know that BC is chord. BC is a chord of smaller circle, and AD is a chord of bigger circle. Okay. Considering outer circle, AB is its chord, smaller circle, BC is its chord. So start with a perpendicular. Here construction is required, that is perpendicular. Draw perpendicular from center to the chord. Okay, to the line that becomes to the chord. Let it be M. So construction. Draw OM perpendicular AD. Okay, draw OM perpendicular AD. We know that perpendicular from the center to a chord bisects the chord. Now, here OM is perpendicular BC as well as perpendicular to AD, and BC and AD are two chords, different chords. Okay, BC is a chord of circle with center O, a smaller circle with center O, and AD is a chord of bigger circle with center O, outer circle. Okay, so consider smaller one. BC is bisected by OM. When you consider bigger one, AD is bisected by OM. So let's start with the bigger one on AD. Okay, using chord AD. What is OM? Perpendicular to AD. Here, start. OM perpendicular AD. AD is chord, which implies AM equal to OM perpendicular AD implies AM equal to DM. AM and DM are equal. Reason perpendicular from the center of a circle to the chord bisect the chord. Bisects the chord. Okay, so that is why AM equal to DM. That will be equation number 1. Similarly, OM perpendicular, which is second chord, smaller chord, BC, which implies BC also chord. So BC is divided into equal parts. Which are the parts? BM and CM. BM equal to CM. That will be equation number 2. Reason same reason. Now, what is to prove here? AB and CD are equal. AB and CD. Okay. What are AB and CD? The excess portion from BC after extension. Okay. So we have to subtract BC from AD. Then we will have AB and CD. So subtract the equal parts to get the answer AB equal to CD. So from the first equation we have AM equal to DM. From second equation we have DM equal to CM. Now subtract 1 minus 2 implies subtract 1 and 2. Okay, subtract left side and subtract right side. Which is left side? AM, BM. AM minus BM equal to right side DM minus CM. Okay, which implies. Now come to the figure. What is AM minus BM in the figure? AM minus BM in the figure is AB. Okay, AM minus BM portion removed. So AB remaining. DM minus DM. DM minus CM. This is removed. So DC remaining, that is CD. So AB equal to CD. Now question number 4 completed. Okay. Question number 5. 3 girls, Reshma, Salma and Mandeep, are playing a game by standing on a circle of radius 5 meters drawn in a park. Okay. Reshma throws a ball to Salma. Salma to Mandeep. Mandeep to Reshma. Okay. They are playing by throwing a ball. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meters each, what is the distance between Reshma and Mandeep? Okay, they are playing in a circular park. So standing on a circle, they are playing in a park and they are standing on a circle. Okay, let O be the center of circle. First name Reshma. Let it be, this be Reshma. Okay, Reshma. Second one, Salma. Salma. Reshma and Salma. Reshma and Salma distance 6 meters. Okay. Salma and Mandeep. Salma and Mandeep again 6 meters. Let it be M. R represent Reshma. S represent Salma. M represent Mandeep. And this is also 6 meters. Okay. Now join this MR. This is the distance between, MR is the distance between Reshma and Mandeep. That is question. What is the distance between Reshma and Mandeep? We have to find out this one. Okay. So for that, join OS. What is OS? O is center of circle. Then what is OS? O is radius. OS is radius. Okay. Radius is given here. What is the radius of this circle? A circle of radius 5 meters. So this is 5 meters. Let this point, the meeting point between this RM is a chord. Okay, because the children are standing on circle. So points on circle. The right segment joining any 2 points on circle form a chord. So RM is a chord. Okay, let them meeting at P. Okay. So here we get these line segments are perpendicular to each other. Why? What type of triangle is this one? Triangle RSM. Triangle RSM is, what type of triangle is triangle RSM? Triangle RSM is isosceles triangle because these two sides are equal. In an isosceles triangle, the perpendicular, when you draw a perpendicular to one side from the vertex angle, what is vertex angle? Vertex angle is the angle formed by equal sides. So this here S is the vertex angle. So if you draw a perpendicular from vertex angle to the other side, unequal side, okay, it will bisect this side in an isosceles triangle. Okay, so this is perpendicular. Also, P is midpoint now. Now, what is OP? Here now we have P is midpoint. Then what is OP? Line segment joining from the center of a circle to the midpoint of a chord is perpendicular to the chord. Okay, that is theorem. So OP becomes perpendicular bisector of MR. So here SP is perpendicular bisector of MR. Also OP is perpendicular bisector of MR. That means OS is a straight line. So what is OS actually here? OS is radius. So OS and MR are perpendicular to each other. Here OS is perpendicular bisector of MR. Okay, so write that as a property. So let's start. Here, join MR implies triangle MSR is isosceles with MS equal to RS. Okay, 6 meter each. Next, the perpendicular drawn from the vertex angle of an isosceles triangle bisects the third side, which implies OP is also a perpendicular bisector of MR. Okay, which implies OS is the perpendicular bisector of MR. Here OIS is perpendicular bisector of MR. Okay. Now, so P is the midpoint of RM, and now join this one also. Now we have a new triangle ORS. Now consider this triangle ORS. Okay, and find the area of this angle ORS. Then using error formula, then you can find out the measure of RP. RP is altitude, perpendicular. Using half BH, you can find out RP. So when you, after getting RP, you can find MP also, because RP and MP are equal. Okay, now, so measure of this OR is 5. This is also radius. Drawing OR. Now, in triangle ORS by Heron formula, which are A, B and C, 3 sides, 6, 5, 5. A equal to 5, B equal to 5, C equal to 6, implies X equal to 5 plus 6 by 2, that is 16 by 2 equal to 8. Now we have A, B, C and S. Now use Heron formula to find the area. Area triangle OSR equal to root of S into S minus A into S minus B into S minus C equal to root of, what is S, 8. 8 minus 5 into, again 8 minus 5 into, third 8 minus 6. Okay, root of 8 into 8 minus 5 is 3. 3 into here 8 minus 6 is 2. Okay, now factorize. 8 can be written as 2 into 2 into 2, 3 2's. Now 2 3's, then 1 2 equal to, how many 2's total? Total 4 2's. So take 2 2's outside. 2 of them comes outside, and from 2 3's, 1 of them comes outside. So 2 into 2, 4 into 3, 12 SQ meter. This is area of this triangle using Heron formula. Now with the help of half BH formula to get RP. Okay, use that formula also. Also, area triangle ORS equal to half BH, which is equal to 12. Okay, area remains same always. Half into, what should be base? This is altitude, so base is OS. OS into base, its height is RP. RP equal to 12, which implies half into OS is, this OS is radius. 5 into RP unknown equal to 12. Okay, which implies here cannot be simplified. So this becomes 5 by 2. So RP equal to 12. This 2 becomes into 2. Then this becomes by 5. 12 into 2 by 5. Okay, numerator becomes denominator and denominator becomes numerator. Okay, when transposing, which implies RP equal to 24 by 5. That is 4.8 meter. RP is 4.8. And therefore, what is to find out here? The distance between Reshma and Mandir, which implies RM equal to 4.8 into 2, double, 9.6 meter. Reason RP equal to MP. Okay, therefore, the distance between Reshma and Mandir is 9.6 meter. Okay, question number 5 completed. Next, one more question is there. Question number 6. Write that question as homework. Okay.